it's time for the awesome Matz to give us the keynote. So let's get started and welcome him on stage.
Giving a keynote in English make me nervous every time. But I believe you can stand. Okay, so recent years, we are working on something named Ruby 3. Ruby 3 is the future Ruby for some distant future. No, you will not get Ruby 3 in this year, nor next year, but some distant future. But in that sense, Ruby 3 is a vaporware. So it's just vague ideas. But since it is a vague idea, the set of vague ideas, so these ideas are very fragile. But at least, we need some goals. So to progress the Ruby community, and especially Ruby core community, we have some kind of the goal, or in other words, the bite to work on. So, but a very important aspect of future Ruby is that it should be compatible to the current Ruby. Just because we had a huge gap when we moved from 1.8 to 1.9, it was terrific. We needed to support some the multiple encoding or Unicode, better Unicode support, but it was pain. So we don't want that kind of pain in the foreseeable future. So the Ruby 3. Despite the fact that we are trying to introduce many dramatic features, but we try our best to keep compatibility, except for the very slight ones. So the key features for Ruby 3 will be performance and concurrency and typing. So for performance, we have some kind of slogan or key phrase that is the Ruby 3 times 3. That means the Ruby 3 will be 3 times faster than Ruby 2. That sounds nice, right? So we are doing some kind of the GC improvement or the VM improvement or some kind of the optimization and de-optimization. Well, we are investigating about introducing JIT to the Ruby virtual machine. And then, but making Ruby 3 times faster is not really an easy task. Just because we are working on Ruby language and Ruby interpreters for last more than 20 years. So we already have picked some low-hanging fruits. So it's not that easy to make it 3 times faster. So here's a trick. So we compare Ruby 3 to Ruby 2.0, which is, 3-year-old something. So we have improved Ruby 2 from Ruby 2.0 to Ruby 2.1 to the latest version, Ruby 3. Each year, we have improved 5 to 10%. Like Ruby 2.1 is the 10% faster than Ruby 2.0. And the Ruby 2.1 is 5% faster than Ruby 2.1, for example. So we want to include that kind of effort we have made. So actually, each year we introduced the Ruby 2 something. We are going to release Ruby 2.4 in December this year. So, and then each version getting faster and faster and better. So we want to include that kind of effort into Ruby 3. And then, so in addition, so we cannot make everything 3 times faster. So we pick some benchmarks. So with that benchmarks, Ruby 3 will run faster than Ruby 2.0, right? So then these benchmarks should be small, just because we don't want to install whole, say, this course or some huge web application to benchmark. So these benchmarks should be small, but not too artificial, like the calculating factorial or some kind of a silly benchmark. That is insane. So they should be small, but not too artificial. So this is the performance improvement we are going to add in Ruby 3. Next, concurrency. So I started designing Ruby and developing Ruby in 1993. It was, 23 years ago. Whoa. And back then, the computers had only one CPU per computer. So we don't have to care about the threading, the parallelism, just because only one execution at the time in the CPU, right? So I didn't care about the concurrence, parallelism, not concurrency. I care about the concurrency. For that reason, I added threads into the language. But I didn't care about the parallelism. But these days, we have multi-core age. We have 2-core, dual cores, quad-core, octa-core CPU in a machine, even in a laptop or even in the smartphones. So in those days, everyone wants concurrency and parallelism. So the people want to use that kind of concurrency and parallelism by using threads. But we have issues in thread programming, especially in Ruby, which is GIL, stands for the Giant Interpreter Lock. So by the effect of the GIL, in Ruby virtual machine, only one thread runs at a time in a virtual machine. So no parallelism. So only one thread, even in the multi-core machine. So that is the kind of the trade-off between the performance and the safety. Because we have multi-core in a machine, so we want to utilize those cores for performance, right? But at the same time, having threads running through independently without synchronization, it's quite difficult to program correctly. So by modifying a few lines of code, you can remove the GIL from Ruby virtual machine. But I'm pretty sure that your program with thread will crash, for sure. If you doubt, try it. It will surely crash. So the Ruby virtual machine takes safety for priority. But just because the threading is hard, unless the language like Elixir. So for that reason, we concluded we need better abstraction for concurrency. So we investigated. We found several candidates. One is actor model, or streaming model, or ownership model. These are the 3 candidates. And last year, how many of you attended last year, EuRuKo? Oh, yeah. In the keynote, I talked about the concurrency, and I talked about the stream model. But last year, we have made a decision that we gave up stream model, unfortunately. So we took some kind of ownership model, but with slight modification and improvement, which is called the membership model. The important point is we need the name for that kind of concept, like actor, sounds nice. Thread, sounds nice. Fibers, sounds nice. Whatchamacallit for our abstraction. So the Koichi, who is in charge of the virtual machine, have been thinking about this idea for years, but we haven't come up with a good name for that concept. But recently, finally, we got the name for that kind of idea, which is guild. Yeah, praise should go to Koichi. Guild is the organization of craftsmanship or something like that, or in the role-playing games, like the congregation of the adventurer or something like that. Like, okay, in this guild model, each object is a member of a guild. You can transfer membership of an object to another guild. You can only transfer. So the object have to be moved, not copied. That kind of transfers can be done by channels. Think about some kind of the Go routine with some isolation on top of the current Ruby model. It's similar to the actor model or Go routine, and then it shares almost nothing mutable. And then, but the classes and the modules are shared, and we will still have Geo, the guild interpreter lock. So each guilds are isolated, so you can run the parallel, multiple guilds in parallel. And then these guilds can be communicate via channels. But inside the guild, you can still have threads inside of the guilds. And those guilds are exclusively locked using the guild interpreter lock. Only one thread runs at a time in a guild. But in a different guild, the other threads can run in parallel. We provide the concurrency abstraction with compatibility, and then you can have less bugs. And as I said, we gave up the stream model, and I still experimented that model in a different language than the stream. This is my toy language with the streaming model on the GitHub. You can check out and play with it. This is concurrency. The final one, the biggest topic in this keynote is typing. So in this decade, we have a lot of new programming language, and most of them are statically typed. For example, TypeScript, Flow, Go language, Swift. And so, the static typed language are very popular and very, new kids in the corner. So I'm sick of some kind of hostile claims, like Ruby is dead, Rails is dead, just because we don't have static typing or something like that. Who cares? we should not be like tumbleweeds, like in the Western movies. The technology comes and goes like a pendulum. For example, in the 80s, we have the dynamic types programming language like Lisp and Smalltalk in the object-oriented field. But many people, especially mainstreams, move toward the statically typed object-oriented programming language like Java. But some camps in the Java field, some people in the Java field move to Ruby and JavaScript, which is the dynamically typed programming language. Then later, some of those people working on the Ruby and JavaScript move to the statically typed programming language, like a Swift and Go, or maybe TypeScript. So that kind of movement happens every other decade or so. So what about the future? Maybe we might move toward statically typed language, toward the dynamically typed language. So as a front runner, we have to think about the future. We have to think about the future of dynamic typing. So let me think about it. Let us think about it. What is type for dynamic typed programming language like Ruby? So in some statically typed programming language, so the class is a type, right? But for Ruby and other dynamically typed programming language, so class is not type. So in the sense of types, we have some principle named dark typing, like this. No. So dark type means it walks like a duck, quacks like a duck. It is a duck. We assume it is a duck. So dark typing is this. This is a duck because it quacks. Or this is a duck because it looks like a duck. So we don't care about the inheritance. We don't care about the internal structure. We just care about how it behaves. So we can ignore inside detail. Things should just work. That's the Ruby way. That's the Ruby way. We don't have to care about inheritance, nominal types, or classes. Things should just work to reduce our brain consumption. So our brain power is a limited resource, so we have to reduce that consumption. So for the example, dark type examples, this is the very simple one. We have the log function to the destination with the message. Okay, static type version might look like this. This destination IO and the message strings. But what if we want to redirect the message, the log messages, to a string? So in Ruby, we have string IO, so we can do that. The create string IO, the log, the error message into the string IO, and we can retrieve the log messages as a string, right? But the static type version doesn't work, just because string IO does not have common ancestors, superclass, inheritance, interface to IO. So the static type check fails in a compile time. So in that sense, dark typing allows you to ignore internals and lower mental costs in development, right? So dark typing is open for the future. So you don't have to care about the future. So the future is opened by dark typing. So dark typing enhances flexibility. So in the sense that in Ruby, the type is dark. Dark is not nominal type. Dark is not a class. So what is dark? Dark is an expected behavior. Dark expected behavior. Expectation in our mind. So the typing by class is only an approximation. Typing by class is too restrictive. So in static typing, in nominal static typing, there's something called, in the research of the static typing, there's something called the structural typing, which is in contrast of the nominal typing. For example, the Go language has the structural typing. So Go interface is structural, for example, like this. That define some kind of the structure, which is the interface with the right method in it. So everything which has the right method can be called, can be used as a destination. So the structures means common behavior. So Go interface is a static explicit definition of the expected behavior. So structure typing is awesome. But in Ruby, we have different very important principle, named dry. Don't repeat yourself, as you know. So by dry, we try to avoid redundancy as much as possible. So in an extreme way, if you can write or execute a program without something, just remove it in an extreme way. So Ruby programs runs without type annotation. Right now, that means we don't need them. We need to remove them. So dynamic typing is better in that sense. But at the same time, dynamic typing has its drawbacks. So error is only found in runtime. So you have to write the complete test compared to the other static type programming language. So the compiler finds many errors in compile time as a form of the type contradiction. And in addition, we might have bad error message like a undefined method, something for new class or something like that. And then without class annotation, we have less documents. For example, like this, we write type information here in a comment. That is some kind of a contradiction. I don't want to specify types. Type annotation, yeah, we need to remove the type annotation just because the program works without any type annotation. So for flexibility and the productivity and less code, so I don't want to write type annotation. But we need documentation for as a user. For API users, we want to know about this method takes which kind of object or something like that. So if we put type information in the documentation or comments, it's kind of like a static typing without enforcement, without any compile time check. That means that's the worst of both worlds. So introducing type annotation is a bad idea, I think. The mixed gradual typing is a bad idea, I think, at least for Ruby language. So here's a room for improvement. Here's the issue. So we are engineers. We try to solve problems with technologies, right? So we see the problem. We seek the solution. So how about type inferences? So we know several languages with type inferencing, like a Scala, or maybe Haskell, or OCaml. So type inference is nice. We don't have to write a type annotation, but the compiler detects the type information and tells you what type you're expecting, right? So we almost don't need to write type annotations with type inference. But still, we can have the static types. The static type with type inference seems to be the best of both worlds, just because you have the compile time type check in a to detect error, and then still you don't have to write types. And the compiler tells you what I expect in the code as a type, especially with the structural typing. So in combination, it is very similar to duck typing. So for example, that add inference to the last Go interface example. So this example goes like this. And then you can infer. You can have inferences of the type of these two arguments from the code. That looks almost same as Ruby, right? So I call those kind of type inferences in Ruby a duck inference. Duck inference is almost equal to structured typing with inference, a la OCaml. But duck inference is a type system defined by the behavior. The behavior is a set of methods and the argument behaviors. So inferred types do not have names. You don't have to think about names. So you don't have to worry about the type names. So vague ideas in your brain can remain vague. So you can retrieve the type of an expression from the compile time messages. So you can have, the compiler will tell you about the type of your code. You can check compatibility between types. You can check if a type has a method. So, but still, duck inference is not perfect. For example, this is the Ruby programs, and then the following is the result of the inferencing. So we have the two distinct types, two ducks, duck A and duck B, which is the generated name. Duck A has a write method with the argument message, and duck B can be anything. So the duck typing don't challenge 100% coverage, unlike other static type programming languages. Like 80% compile time check is far better than 0%. It can fall back to the dynamic typing as Ruby working right now. In addition, we will use some kind of the ad hoc type information. For example, find type errors from the contradiction. Like from last example, message is the argument of write. Then all write methods in a application takes a string as an argument. This is the fact. So by combination of these facts, message should behave like a strings. So you can infer one step further. Or assume the variable A expected to have method gsub and slice and map. So you find the code calls those three methods to the variable named A. But right in the system, in the applications, no class has these three methods. That means it should be an error. So you can add that kind of ad hoc knowledge. You can detect more errors than the simple inference. Or maybe you can use runtime type information. For example, the correct type data at runtime, especially from tests. You write tests, right? Me don't. Sometimes. But in tests, most of the code should behave correctly. You supply the correct argument types in the test, right? So by collecting this information makes the knowledge in a database, the type database, in what you expected as an argument type or return values. So then you can build those kind of the type databases for your application and for your gem. You can ship those kind of database with your gem in the future, of course. Then that enables more accurate compile time check, or maybe the type information can be for your application or for your gem can be accessed as a database. Then your IDE or editors can. It is possible to use it for productivity, like code completion or refactoring. In the future, of course. That sounds awesome. Right? Sounds awesome. But you can use it now. Yeah, it is still mere concept, and we are under the experiment. But as part of the research projects. Yeah, we do many things in the experiment of the future Ruby. So the important message is Ruby should progress. You know, old languages, many of old languages stop progressing. Then in the community stop increasing, and the community and the open source gradually dies. I don't want that kind of things. I don't want Ruby community to be dead. So I don't want Ruby, the language, and the Ruby community, and the whole Ruby ecosystems to keep moving forward. So we need something, some motivation or driving force to move forward. So we need something to make us motivated. To each Ruby programmers, to Ruby core committers, to myself. So to make that biggest reason is to make us more productive and to make ourselves enjoy programming. Because we care about you. We care about you Ruby programmers. Because we care about how you feel during your programming, especially using Ruby. We are willing to improve your development experiences. So the biggest question you might have is when will it be available? The short answer is, I don't know. The longer answer is years. Some Christmas. We have a lot of things to do. Dark inferences, really 3x3, and guild, and more. So we have a lot of ideas to implement before Ruby 3. So you have to wait for years, unfortunately. But we welcome your inputs and the contribution, especially ideas. And we welcome your contribution to keep us moving forward. The Ruby community, each Ruby users need to keep moving forward, need to progress. You have to keep moving forward. So that is the most important message, and the biggest motivation behind the Ruby 3 project. Ruby 3 project, yeah, whatever, is our driving force. The most important aspect of Ruby 3 is our driving force to keep us moving forward. So let's program in Ruby. Let's enjoy it. Let's think about improvement of our ecosystems and the language to keep moving forward and better programmers, to become better programmers. So this is my message and the end of my keynote. Happy hacking.
Thank you, Matz.